For exome capture projects, Seekman Pro's Exome Coverage Report lets you check the amount of coverage for each region by depth and percent. Prior to filming this video, I performed an assembly in Seekman NGen using the human genome as a template. Here, I've opened the resulting .assembly file in Seekman Pro. To view the Exome Coverage Report, all we need to do is choose Project, Show Coverage of Target Regions. Seekman Pro then prompts us to select an exome coverage file, which has the extension BED. This file is generated by the sequence provider and is normally located with or near your other sequencing files. Once we've navigated to the file, we'll click Open to launch the report. The Exome Coverage Report provides information about capture regions for each sample. In the example used in this video, the .BED file contained data for 230,000 regions on 24 chromosomes. Before continuing, we can color the table to make different groups stand out more. To do this, we'll click on the Project Parameters command. Next, we'll choose Editing and Color, and then we'll add a check mark next to Use Colors in Targeted Coverage window. And finally, click OK. Now we can sort the table by clicking on any column header. For instance, I can click on Feature, and this sorts the rows according to the feature and also makes each gene a different color. Clicking on other columns would allow us to sort based on contig or chromosome ID, exome length, or the number of reads or SNPs in the exome. We can also sort using multiple criteria by using the View Sort command. By default, this is going to sort by contig ID, in our case that's also the chromosome ID, in ascending order. And to add another search term, I'll just click on the plus sign. In this case, I want to then sort by the feature in ascending order. And finally, I'll click on the plus sign again. I want to sort by the RPKM value in descending order. Finally, we just click the Sort Now and then the Done button to return to the Exome Coverage Report. And here's the report sorted in the order that we specified. We can judge the adequacy of exome capture by looking at the coverage depth column, or the percent covered column, or by using RPKM, which is calculated using the other two values. RPKM stands for Reads Assigned per Kilobase of Target per million mapped reads. An RPKM of 10 or above is considered a good capture. Conversely, if the RPKM is 0, this means that either the probe failed to capture those sequence fragments, or there's a potential error in the .BED file, and another possibility is that there's a repeated sequence and all of the repeated reads were assigned to the other replicate. If we check the Show RPKM Distribution box, we can view a bar graph showing the distribution of RPKM for the entire dataset. Here we can see that the mean RPKM for this dataset is 10. To open the alignment view for a particular capture region, we can just double-click on its row. Here, I've sorted according to the features. Note that the feature DSPP has RPKM values ranging from 7.29 to over 1,000. First, I'll open the alignment view for the sample with the RPKM of 7.29. The alignment view shows relatively low coverage here. Now I'll double-click on a region that has an RPKM of 233. And scrolling down the alignment view, we can verify that this region does have very deep coverage. To save the Exome Coverage Report as a tab-delimited file, select File, Save Targeted Regions Report for.